Okay, this is take one. Back at it again. Lab coat, closed-toed shoes, gloves, glasses, transition. Are we ready? It still wasn't that great, but it was better than last time, and I knew it. So let's get started. I was testing the samples that we worked on from the last video that I did. So I had 12 that I needed to take 20 microliters of, but I only had 6 flasks. So here I am, I'm labeling them according to which sample I'm taking. There was R1, R2, and AT. That refers to the reactors or the acid trap and at which hour it was taken. So I think it was 4, 8, 13, and 18 hours. Here I took a little time lapse. It actually went like ridiculously fast, but this is me taking all 20 microliters of each sample and then putting it into the volumetrics. Then I had to dilute it to 50 mils, which makes it a 2,500 times dilution. Like it was diluted 2,500 times. You get that from dividing 50 milliliters by 0.02 mils, which is the 20 microliters. And then I had to like mix them up, you know? The last time I had this, handy dandy little water jug thing. I thought I'd kind of explain it, or at least try to, because I thought it was pretty fun. I like using it. Basically, like, it's got this closed container. The only part that's open is this tube. The way it works is that water will only come out when it is below the water level. So here I am pouring it. I'm gonna spill. 3, 2, 1. There it is. Okay, so I spill it, but the water is only flowing because the gravity and the water pressure are acting on it, like, only when it's below that water level. It all has to do with pressure and gravity. And it's either like no pressure or it's like equal or something when it's above the water line. I decided to do it again because look, it's just so cool that no water comes out until it is below the line. Physics is neat. I've actually never taken a physics class. Fun fact. Taken a lot of other science classes though. But here's just me filling up DI water. And DI stands for deionized. I didn't ever specify that. But yeah. I'm gonna spray my phone again on accident, but with a lot more force than last time. Yeah. Anyways, here's me finishing the dilutions because I had to get more water. And then here's me indicating that I had to do this twice over because again, I had 12 samples but only 6 flasks. So times 2, boom, there are the rest of them. But I think I actually recorded me preparing them, and this is just long, so this is my first time recording this through, but maybe I can explain my experiment. So basically we're trying to push air through wastewater or mock wastewater that has a lot of ammonia in it, because we're trying to strip the ammonia so that it can be used to turn into fertilizer. So basically whatever numbers we get from this sample, it'll indicate like how efficient is this, like how much ammonia is actually in these samples like after the 18 hours. So yeah, we're trying to quantify it, but I have to dilute it first because obviously there's a lot of ammonia in it. But anyways, by the time it was all done mixing, I had to put it into these like big old vials, and they're all labeled nice and neatly because I like to organize my stuff. And after that, I had to take off all the stickers because, you still have to do dishes at home, in the lab. You don't really get out of doing dishes and cleaning up after yourself. So I only had 6 though, so it's not too bad. Basically just like rinsing it. It's nothing crazy. Like there's just not a lot of gunk on these things. Actually, now that I'm recording this, I forgot that at some point I started playing music in the lab. So there's probably music in some of these clips. But anyways, after this, we actually went to a different lab to do the testing. There's some things that we had to add to it. It was like 2 powders. I think one of them is like salicylate and the other one is like cyarinate or something like that. I don't know. But so now all that diluted sample that I had to take, I took 100 microliters of that and mixed it with the 2 powders. Oh, this is such a fun little thing that mixes it up. But anyways, once all of the stuff was added to it, we had to wait 20 minutes before actually running it through something that would read the color. Green means more ammonia. That's it. And clearly you can see that at different times and through different reactors, it's different colors, which is good. We want that. But that's it. That's pretty much my day in the lab. Did a lot of testing and it was very fun, and I had my lunch. Boom, I did this in one try. Let's go.